1. Let's take a look at the equation that you have just written. 5.1. Okay, so this over here was the equation that you have just written. This one, x plus 3 equals to 8. Where is the variable? Which one is the variable? The x, right? What is the power? 1. The highest power is 1. So this is a linear equation. That's all that there is to it. So is x plus 3 equal to 8 a linear equation? Yes. Explain. There is only one variable and the highest power is 1. So copy the answer down over here. Yes, there is only one variable. The highest power is 1. And then what is the value of x? All of you knew already. It was 5. The value of x was 5. Okay? Now next, when we ask you to solve the linear equation, so we're just making sure, familiarizing you with the terms that we use. When we say solve the linear equation, now you know what a linear equation is. Linear equation is just a line. It has an equal sign. There's a left hand side, there's a right hand side. It has variables. The variable highest power is 1. Okay, when we ask you to solve it, we're actually asking you to find the value of x. That means fill in the blank in the box. What is that value of? What is the value that goes inside the box such that the left hand side equals to the right hand side? Which all of you could do earlier on. You told me the answer was 5. Okay, so the blank over here is x satisfies. What does it mean by solve the linear equation? Find the value of x such that left hand side equals right hand side. The value of x will satisfy. Okay, satisfies the equation. Yes?
What do you mean by the highest power of 0 is 1?
Okay, are there cases where we have an equation? That means there's a left hand side, there's a right hand side with an equal sign. The highest power is not 1. For example, for example, power is 2. For example, x to the power of 2 plus 3x plus 6 equals to 78. For example, this is an equation. There's a left hand side, there's a right hand side. We have variable of x, but the highest power is 2. So this is not linear because the highest power is 2. Okay?
What if the highest power is 2 or higher, then it's not called?
Then what is it called? Is it?
Yeah.
Okay, then this is called quadratic. Do you need to know? Yeah, you need to know in Sec 2. In Sec 2, you need to know the higher power. When it is 2, it's called quadratic. Or what if we go up higher power? It is called cubic. Then you learn that in Sec 3. Okay, but for now, we are just dealing with linear. Power 1 only. Simple. Okay? Okay, now the value of x is called the solution. So when you see this, x plus 3 equals to 8, you should be thinking, so simple. X is just equal to 5. Congratulations, you know the solution. Solution is just 5. Another word is called root. We hardly use this word in lower secondary.
Yeah.
The root, the solution, they mean the same thing. Just for your knowledge only, okay? When you see the word root, they're talking about solution. Nothing more. Nothing complicated about that. Okay, so now we'll skip this portion. Okay, let's go on to the next page. You know, our equations actually can be illustrated or pictured with a seesaw or balance beam. Or we have a left hand side, we have a right hand side, and in the middle, this is our equal sign. Okay, put down the equal sign in your seesaw. So the left hand side equals to the right hand side. So that is balanced. If it is not balanced, then you don't have an equation. They are no longer equal. Alright? Now, how do we find the weight of one ball? I've got 20 kg, it's the same as the mass of 4 balls. What about the mass of one ball? What should we do? What should we do? Divide by what? So in this blank, well, for W, where W is the weight or the mass of one ball, okay? Let W be the weight of one ball. For W equals to 20. So on both sides, okay, all watch, stop talking. Look at the screen. To keep the seesaw balanced, this is the first principle. Whatever you do on one side, you must do on the other side. Otherwise, not balanced, right? Can you imagine, you add something to the left-hand side, but you don't add the same thing to the right-hand side. Will they stay balanced? It won't. If you take away something from the left-hand side, but you don't take away the same thing from the right-hand side, will they stay balanced? Also won't. Similarly, for multiplication and division, square root, square, so on and so forth. So here, we want the value of W only, 1 W. So we need to divide by 4. In order for the seesaw to stay balanced, we also need to divide by 4 on the other side. Therefore, leaving us with W equals to 5 kg. Okay, now we have the next example over here. 18 and 3 balls with a 6. So how do we find the weight of one ball? Again, you need to define. Let B be the weight of one ball this time. Earlier in the question, we used W. But this time, maybe it's different. So let's just call it B. B for the weight of one ball, we form an equation. Now on the left-hand side, okay, they switched it around in the equation when they wrote it, but it doesn't matter, left-hand side, right-hand side. Here we have 18. The same 18 that is found on one side of the equation. On the other side of the equation, you let the mass be B already. So I've got 3 B's. 18 is equal to 3 B's plus another 6. So 3B plus 6. That is the left-hand side of the equation. Now that we have this, I only want to find the value of B. Okay?
So 18 minus 6.
Okay, hang on first. I only want the value of B. But you see that the B currently is accompanied by a lot of nonsense, right? We've got a 3 in front of B, that is called the coefficient. I want to remove that. Then the 3B has an addition of 6. I also want to remove that. I want to remove everything such that I'm only left with B. That is my objective. So what can I remove first? Can I remove the 3 or can I remove the 6? Okay, what goes first? What should we remove first? Okay, looking at this diagram, what do we remove first? You remove the 6 first, right? How do you remove the 6? Okay, so this is another term that I'm going to be using very commonly. Removing something on both sides. Removing the 6 on both sides. How do we do that? We will subtract 6 on both sides. Okay? So you minus 6 on both sides. When you take away 6, we left with 3B equals to 12 kg. Okay, I'm not going to write down units over here first. So you took away 6 on both sides. And now I'm left with 3B equals to 12. I want to remove the 3. How do I do so? Divided by 3. Or is it minus 3? Should I divide by 3 or do I minus 3? Divide by 3. You can see that minus 3 doesn't help me at all. I've got 3B equals to 12. I want 1B only, so I must divide by 3. You have no choice. So we end up with B equals to 4. So what may appear to be complicated? What may appear to be a complicated equation, 3B plus 6 is 18, it's actually quite simple. Whatever you do on one side, you do on the other side. Such that you get, finally, the unknown that you want. Subtraction. So if we see in the question 3B plus 6, I need to reverse the plus 6. Therefore, I will minus 6. Removing the positive 6 by subtracting 6. So obviously, the opposite of your subtraction will be your addition, multiply, divide, divide, multiply. If you have a square on one side, for example, x squared equals to 25. Then what is x? So you need to reverse it. You reverse by taking the square root. So square root of 25. So likewise for the rest, point number 6, 7 and 8, self-explanatory. Okay, then let's get started. Exercise number 1. Solve the following equation, meaning find x. Find the value of x such that the left hand side goes to the right hand side. What is the answer over here? What is the value of x? It's 7 plus 2. So we do the reverse of your minus 2, which is plus 2. X equals to 7 plus 2, which is 9. Honestly, do we need to write down that particular working? No need lah. Everybody see, you know it's 9 already, right? For that, as simple as this, you don't have to show working. Okay? But since we're all starting, let's practice it correctly first. So x equals to, I want to remove the negative 2. I remove the negative 2 by adding 2. 7 plus 2. X equals to 9. Okay? So, over here, what I've done is to add 2 to both sides. This in green is called removing the negative 2. I add 2 to a negative 2, then it will be removed. I must do the same on the other side. For those of you who have tuition or you have brother, sister, mother, father teaching you, they might have said things like this. Listen carefully, They might have said things like this. You see the negative 2, right? You bring over, then the sign will change to become plus 2. Heard before? Who heard before? Confirm here before. I will tell you right now that that is not wrong. But my concern is, do you know what is happening? Why should there be such a thing? Wow, one side bring to the other side, the sign will magically change. Then you'll be correct. Do you know what's happening or not? Can you really accept that explanation? If you can accept the explanation, then I think it's because of the idea of whatever you do on one side, you have to do on the other side. And whatever you're doing on one side, in this case, is to add 2. So you also add 2 to the other side. And why did you even add 2 in the first place? Because you had to remove the negative 2. Okay? Next question. Here we have x plus 5. Without using the one side move to the other side, sign change here and there, whatever it is, which doesn't always work, what should we be doing? To both sides. We have a plus 5. So what should we do? Minus 5 on both sides. This is the correct way of doing it. So x equals to 6. Yes? Okay, go ahead. Yeah, okay. So that is also the reversing. What you're doing is also just reversing. But it becomes more problematic when it comes to x squared, for example. How are you going to reverse it without the idea of reverse operations? Because it will no longer just be your plus and minus when we move on. Okay, so over here. Now, we've got our negative x minus 2 equals to 7. Ask yourself, what is it that you want in the end? What is it that you want right at the end? X, right? Currently, x is attached to many other things. What is your x attached to? There is a negative 2 over here that you want to remove it. So what do we remove? How do we remove the negative 2? You plus 2 on both sides, okay? Do it step by step. Let's see what happens. Plus 2, plus 2. So negative x minus 2 plus 2 gives me simply negative x. Because this action of adding 2 removes the negative 2 already. So on the other side, we have 7 plus 2, which is 9. Okay, now, I got negative x is equal to 9. What do I want to remove this time? 9. Are you sure you want to remove 9? No, you want to remove this particular negative sign. How do we remove that negative sign? How do you do that? Times negative 1. Will that help? Will negative x times negative 1 give me positive x? Think about it. Will negative x times negative 1 give me positive x?
Negative x plus x equals 0.
But I don't want 0, I want x. That's why I said the objective is that I want x equal to something, right? So there is a suggestion to say that we multiply by negative 1. Multiply by negative 1. So my question is, negative x times negative 1, would I give you x? Yes or no?
F0 minus 1.
Hey, why don't you all have confidence? Negative times negative is positive, right? X times 1 is? Hello? So do I have positive x? I do. I have positive x. That is if I multiply by negative 1 on both sides. So this gives me x is negative 9. So it is correct. But is there another way to do this instead of multiplying by negative 1? Any other option? Give me another possibility to go from the second step to the third step. Instead of multiplying by negative 1, what else can we do? And whoever gives me the correct answer, I'll bring a prize for you the next lesson. Instead of multiplying by negative 1, how else can we get to the next step? Huh? No guess and check. How do I go from negative x to positive x if I don't multiply by negative 1? Yes? Hey, what move? What is move? What do you mean by put it at the right side? Equals 9 equals to negative x. What do you want me to write? Where got 7? Don't understand. Try again. I think you're getting somewhere though. Okay, from the equation. Negative 7 minus 2 equals to negative x. Negative 7 minus 2. How do you get this? What do you mean by move? There is no move in my vocab. There is a plus something on both sides. There is a minus something on both sides. There's a multiply something on both sides. Divide something on both sides. Which one is it? She is getting somewhere, but she has a lot of difficulty explaining it. What? Yeah, but there's no move in my vocab. I really taught you all how to say it correctly. Yes. 7 plus negative 2. Why 7 plus negative 2? No, 7 plus negative 2 is not going to give you x. Or 7 plus negative 2 is equal to 7 minus 2, which is 5. Yes? Cross what? What cross the bridge? No bridge. Don't know what bridge you're talking about. Equal sign, equal bridge. Then what happens when the 7 cross the bridge? Y must become negative number when you cross the bridge. No such thing. Come on, any answers? Yes. What? Shift? What do you mean by shift? What happens when you shift the sign? Why will the sign change? Okay, I will give you the solution now. Ready? And it is going to convince you. Okay, in fact, I got two solutions for you. The first, I'm going to build on what Jiaxi said. Okay, so she recognized, hey, there's a negative in front of the x. She don't want a negative. We eventually want it to be positive, right? So, our first step looks like this. This is the question. She doesn't want negative x anymore. Plus x lah. Right? Can I plus x to both sides? Can, why not? Positive x minus x. Any more x? No more x. But I have negative 2 left. Equals to 7 plus x. Okay? So you see, I managed to do this without any bridge crossing lah, move here, move there, change sign or whatever not. What's happening over there? Here we have created the positive x already. And how do we do it? It was simply by adding positive x to both sides. And then logically the next step would therefore be, I want to remove the positive 7 by subtracting 7 on both sides. So I now end up with negative 2 minus 7, which is negative 9, equals to positive x. Then I just switch the position over. Because if negative 9 is equal to x, I'm sure x is equals to negative 9. Right? Okay, so this is building on what Jiaxi said. Was this what you had in mind? Whatever you do on one side, you do on the other side. You, instead of just adding numbers to both sides, you can also add x to both sides. You can minus 2x on both sides if you want to, if that helps you. Okay, but this wasn't what I initially had in mind. Instead of multiplying by negative 1, there is another way. Okay, so I will show you now. If we have 3 apples equals to 12. What is 1 apple equal to? Times up. How do you get 4? 12 divided by 3, right? Okay, now I'm going to change. Instead of the 3 over here, it is going to become, let's say, 8. Then what is going to happen about 1 apple? What is going to happen? Divide by 8. Okay, just change the number, right? Okay, what about instead of 8, I have a weird number, let's say pi. Let's say I have pi over here. Then what happens? Divide by pi lah. No matter what that funny number is, right? Yeah, because this is a multiplication. So if I want to find only one value, I divide lah. Okay, what about if it is a decimal? Will it work? Let's say we have 0.2. Then what is in the denominator? 0.2 lor. What if it is a fraction? Let's say we have 3 over 10. Then what is in the denominator? 0.3, which is 3 over 10 also, right? So you can just put in a fraction over here, 3 over 10. Do you see how this works? Whatever that number is, you just divide it lah. What if it is a negative number? Let's say it is negative 2, which doesn't really make sense, okay? But just treat it as algebra. What do we put in the denominator? What do you put in the denominator? Same law, negative 2. There is no change in the method. I'm very interested in the method as compared to memorizing stuff. So you just divide by negative 2. Now what if it is a negative 1? What should we do? Divide by negative 1. So do you have the answer already? Let's divide by negative 1. So instead of multiplying by negative 1, you can also divide by negative 1 and get the same answer. Next question. Okay, what should we do to get rid of the positive 5? Part D. How do we get rid of the positive 5? What should we do? Think. Okay, so we minus 5 on both sides, right? Minus 5. So in another color, negative x equals to negative 11 minus 5. That is negative 16. Also, what is x equal to? If negative x is equal to 16, Oh, sorry, negative x is negative 16. What must x be? What did you do on both sides? Take away the minus. How do you take away the minus? Times minus 1 or divide by negative 1 also can, right? Or if you want, you can add x to both sides. Then you add 16 to both sides. Also the same. So here I choose to divide by negative 1 lah. Divide by negative 1. And I get 16. Whatever you do on one side, you must do on the other side. Okay, part E now. 9x equals to, wow, this is so simple. Okay, what is x? What is x? 21 over 9. 21 over 9. And simplify, what do we have? 7 over 3. No need mixed fraction, you can leave it like this. Perfectly fine in secondary school. Next. Okay, part F. Try it yourself now. Do the substitution and check whether your answer is correct. Okay, so now we want to remove the positive 17 first. We do so by subtracting 17 on both sides, leaving us with negative 6w is negative 1 minus 17, negative 18. Okay, then I only want the w. I want to remove the negative 6. How do I do that? I divide by the coefficient, which is negative 6, resulting in w equals to 3. So whatever answers you got, you substitute your answer back into the question. 17 minus 18. Oh yeah, I do get negative 1, which is the right hand side. So I'm sure my answer is correct. How about yours? If you did not get a 3, if you did not get positive 3, when you substitute it back into the original question, you will not have negative 1 as the answer. And then it's an indication that your answer is wrong. Can? 1 over 4x equals to 5. Is it correct? Is it the same? X over 4 is the same as 1/4 x, isn't it? They are the same. Then we go back to earlier on. What do we do? To find the value of x, you simply need to 5 divided by the coefficient of x, which is 1/4. You get 20, right? It works. This is one option. Not my favorite option. Not my favorite option. Then I show you another option. 5 plus 4? Why plus 4? 5 times 4. Okay, hang on. I show you the other option that I have. The other option, please don't copy this down. 5 over 1. I have fraction equals to fraction. I'll show you a neat trick. Do you know do you know the relationship between 1 over 2 and 4 over 8?
Yeah.
They're the same, right? Do you notice? Have you ever noticed in your life, when you take 2 multiplied by 4, the answer is actually the same as 8 multiplied by 1. Have you ever noticed that?
Yeah.
2 multiplied by 4 equals to 8 multiplied by 1, right? Do you know that this always works? For example, 3 over 7. Let's make the denominator 42. 18. Let's try it again. 7 times 18. 7 times 18. That is 126. And then you take 42 times 3. Oh, you also get 126. You know that there's this relationship? Okay. So I'm going to use this relationship over here. X over 4 equals to 5 over 1. And I'm going to draw a little arrow over here. X times 1 equals to 4 times 5. So x equals to 20. Okay, this is the other option. But this is also not my favorite way of doing it. My favorite way of doing it is simply x over 4. X divided by 4 is 5. So I need to reverse the division by 4 times 5. Yeah, simply that. Sorry, times 4. Times 4. Because now the left hand side, x over 4 times 4 equals to 5 times 4. The left hand side, you have them cancel off, leaving us with simply x equals to 20. This is my favorite way of doing it. Okay? Any questions? Let's try part B. What shall we do to both sides? Times 2. Okay, good. Let's multiply by 2. Times 2. Times 2. Seriously, are these arrows necessary? No, they are not. Okay, so here we have x value negative 2. Besides multiplying by 2, we can also divide by half. Next, what shall we do to both sides? What shall we do to both sides? So I taught you 3 different methods. One of them is useful. What should we do to both sides? Similar to the earlier questions, where I did 3 apple equals to, I can't remember, 12. Then I show you pi apple equals to
Negative 7.
what?
Negative 7.
Why times negative 7?
So you exchange the negative to positive.
Then what do you have on the left hand side?
Also both was negative 7.
Yeah, then what do you have on the left hand side?
Left hand side you will have 4x.
Yeah, you will have 4x. Yes, then after you still need to divide by 4, right?
Yeah.
Okay, not wrong. But there's one of the 3 options that I taught you, the very first one. Not the cross. What do we do to both sides? Come on. Divide. Come on. Divide by what? Divide by negative 4 out of 7. Divide by negative 4 out of 7. Right? Whatever is the coefficient, just divide it. If it comes to your negative sign, don't care, just divide. It's a fraction, don't care, divide. Rational, irrational, doesn't matter, just divide it. So we end up with x equals to negative 2 over negative 4 over 7. The way you write fraction in a fraction is important, so that you don't confuse yourself with versus negative 2 over negative 4 over 7. Are they the same? Do you think these two are the same? This fraction and this fraction, are they the same? You try in your calculator. They're not going to be the same. Okay, then from here, this gives us a value of, you can use your calculator for this if you want to. Seven over 2. Okay, this is wrong. How you write the fraction will affect the answer. Okay? Moving on. It is recorded, don't worry, you can watch it at home. Okay, now, part D. Things get more interesting. I want to find the value of x. X is currently stuck in the denominator. What shall we do? Any suggestions? Times x. Times x on both sides? Shall we try that? Okay, let's try. We multiply by x on both sides. So now x is no longer in the denominator. On the left hand side, if I work everything out, this is what we have. Negative 4 over x. You multiply by x on the left hand side. On the right hand side, negative 7 times x. You should be happy to see this, because now you can cancel the x. Yes, you can. Okay, so eventually you all will find ways to simplify your work, but you have to be careful of careless mistake. Okay, so now we end up with negative 4 equals to negative 7x. What should we do next? Okay, get rid of the negative 7 over here. And how do we do so?
Plus 7.
You sure? How do we get rid of the negative 7? Times or divide?
Divide negative 7.
Okay, so it is a coefficient, so just divide by negative 7. Okay, and then on the other side, we end up with negative 4 over negative 7 equals to x. X equals to 4 over 7. This is one way of doing it. There are many ways of doing it. Okay, part E now. What should we get rid of first? What should we remove? Is it the remove the 3 or remove the negative 4 over 7 first?
3.
You have to remove the 3 first. Because the x is attached to the 4 over 7 with the negative 4 over 7. So you need to remove the 3 first, the outer side. So you minus 3 on both sides. Minus 3. Eventually you will not need to draw all these arrows. You don't have to. But for now, I'm guiding you on the steps. So minus 3, leaving us with negative 4 over 7x equals to negative 5. And now, we want only x. What shall we do? What shall we do to both sides?
Times negative 7.
Two options are, first you can divide by negative 4 over 7. Right, the coefficient, negative 4 over 7. That's one way to do it. But I understand that, hey, you know when you divide by a fraction, you're actually doing multiply by flip, right? Divide is actually multiply by flip, isn't it? Okay, in the same way, instead of writing divide, I can write multiply by negative 7 over 4. Multiply by negative 7 over 4. They are the same. Leaving me with x, negative 5, 7 over 4. So we get positive 35 over 4.
Or you can times 7, then divide negative 4.
Same lah, same.
Same thing. That is long one.
Okay, homework, part F. Oh, that's not the end yet. Watch the video. All this homework. Okay, until page 7. Why? That's not a lot. You see, it's just 1, 2, 3, 4, 5, 6, 7, 8. 12 questions. Okay, I give you a discount. Discount. Until page 6, okay? Okay, start on your homework now.